Hi all, Dr. Clark here again. And for Gen Bio today, we're going to talk about hominid evolution. So last time we were talking about primate evolution, which included lemurs and monkeys and other organisms which we consider primates. But now we're going to really look at the hominid line. Okay, so hominid line can be considered bipedal, and it can be considered kind of the direct ancestors to humans, Homo sapiens. Okay, so you can see here from this phylogenetic tree, you can see that we've broken off the pan genera, or the chimpanzee genera. Okay, that's our closest relative. They broke off here. We shared a common ancestor with them somewhere around 5 million, in between 4 million, 5 million years ago. Okay. Then we have the line. Now, it's not shown here, but chimpanzees have a bunch of branches coming off too until they got to the modern species of chimpanzee. But we're not going to talk about the evolution of chimpanzees. If you want to talk about the evolution of chimpanzees, you can take like a mammalogy class, or take an anthropology class. They might talk about the evolution of chimpanzees. A primatology class will definitely talk about evolution of chimpanzees. But we're interested in this line. We're interested in kind of the hominid evolution. And that's what I'm going to spend time today talking about. So after we broke off from the common ancestor to chimpanzees, where did we go? How did we evolve? How many different species are there? And remember, these species are based on mainly fossil evidence. Okay? And like I said before, fossils happen under intense pressure, sometimes intense heat, for long periods of time. Now, if humans are not next to water sources, or hominids are not next to water sources, and they don't die next to water sources, then the odds of producing a fossil is pretty poor. So while we do have fossil evidence for all these species, there could be other species that we have not found yet because the fossils are just not there. So the transitions might not be as drastic as some transitions that we see. Okay? And we'll talk about this as we progress. Okay, so the hominid family tree. The most recent kind of connection, or the most recent fossil specimens, suggest that somewhere between 6 and 7 million years ago is where the hominids started to develop. Now, it could be closer to 4 or 5 million years ago when we separated from chimpanzees, but nonetheless, we know it's kind of in that range. Now, the problem with a lot of these fossils is that they show very modern characteristics, and I don't want to say the problem. This is more of an interesting piece of the fossil. They show some very modern characteristics, and the fact that the organisms were bipedal, and they had kind of the the bone structure that we currently have, or somewhat close to it. But they also had very primitive features. So their skull was very primitive, very large jaw, very small brain. So some of the traits are, it's interesting. You would expect the species to probably not last very long on the planet, given that their features are not very adaptive. Okay, but we'll talk about how long, or estimates of how long each one of these species lasted. Okay. Well, the first real hominid fossil that gave a lot of evidence to the human connection, and was kind of, one of the biggest fossil finds ever, was found in Kenya, in the Rift Valley, in 1995. Okay? And it was dated to 4.2 million years ago. Okay? And most of you probably heard of Lucy. Okay? And this was Lucy, who was an Australopithecus anemes. Okay? Now, this fossil was found to be kind of an intermediate between other fossils, Australopithecus afferens, okay, and Homo. Okay, so it's kind of this connection. Now, Lucy is not part of the Homo genera, and we'll talk about the fossils for Homo, our genus, in a second. Okay, she's the precursor to the Homo genera. Okay? She's the ancestor to the Homo genera, and she's an Australopithecus. And it's that 4.2 million years ago where we still kind of say that's the base of the family tree of humans. That's where we separated from chimpanzee-like ancestors to hominid or human ancestors. Now there are two main differences to classifying Homo, the genera Homo. And this goes for actually all species classification. Whenever you look at species, whether you're trying to classify species of ants, species of ducks, it really makes no difference. There are two different approaches often applied. One is to be a lumper. Okay? Lumpers recognize that small characteristics, small changes in the fossils are not enough to distinguish separate species. Okay, so they tend to lump organisms together, even though there might be differences in the actual physical features, maybe the skull size, maybe the amount of teeth, or something along those lines. They still lump them together. Okay? So in the case of Homo, the genera Homo, if you're in the lumper category, there were 3 species of Homo. Okay? So Australopithecus gave rise to Homo, the genera, and that's our genera, and there's 3 species. And we're one of those 3 species, Homo sapien. Okay? Now, if you're part of the splitters group, they recognize at least 7 species of Homo. Okay? And there are some people that are in between. And they say, well, there's probably more than 3, but there's not quite 7. Okay? So, but most of the time people take one of the 2 camps. Either you're a lumper or you're a splitter. Okay? I'm going to present evidence for the splitters because I think the evidence is fairly compelling for the splitters that there was roughly 6 or 7 species of Homo. And I also think that an issue that we have with the Homo genera is we don't have very many fossils. We don't have enough fossils to be lumping things together. I think we have enough fossils to say that, based on this Homo erectus fossil and this Homo habilis fossil, these are 2 separate species. But again, remember, speciation, if we go with the biological species concept, we will have to suggest that from a fossil you cannot distinguish whether or not those populations can mate. They might have been able to mate together, or they might not have ever mated together. And this is a huge debate with Homo sapien versus Homo neanderthalensis, in the sense that Neanderthals, some people believe, mated with Homo sapiens, that Neanderthals and Homo sapiens are the same species. Okay? Other people believe that they did not mate together. And we have genetic techniques that we've actually pulled Neanderthals out of the ice. So we have the DNA from Neanderthals. And we know differences in the DNA between Homo sapiens and Neanderthals. Now, we know that modern Homo sapiens do have a certain percent of Neanderthal genetics. Okay? Does that mean that we mated together, or does that mean that we evolved from the same common ancestor? We don't know. Right? Could have been both, or it could have been that we just evolved from the same common ancestor. Okay? And we'll talk more about this in a little bit. Okay? So here you can see how this is kind of split out. Okay? So you have these Australopithecus, and there's quite a few different Australopithecus groups, okay, they gave rise to the Homo genera. Now, if you're a lumper, then habilis and rudolfensis is the same species, and it's just considered habilis. If you're, lumping these two, erectus and ergaster, it's just erectus. And these three, there is no neanderthalensis, there's no heidelbergensis, okay? It's just Homo sapien. Okay? So it really just depends on the camp, but nonetheless, we do know that there was at least 3 species of Homo. Okay? I'd say most people actually believe there was at least 6 or 7 species of Homo. Okay? So let's go through and talk about these early Homo species. So again, we evolved from Australopithecines about 2 million years ago. Okay? That's where the Homo line came from. Okay? The first fossil evidence and the first species would have been something that we call Homo habilis. Okay? Now, it had a little bit larger brain than Australopithecus. Now, the key feature, a lot of the key features that we concentrate on when we talk about the Homo genera, because we're comparing the Homo genera to the Pan genera. So, chimpanzees are our closest living relative. And so we can look at the skull of a chimpanzee, and we can compare it to the human skull, and we know that we have a much bigger brain than chimpanzees do. Okay? They have a much bigger jaw than we do. So a lot of the features, when we start looking at these early humans, a lot of the features are based purely on like the skull size. How big was the brain cavity? That in turn tells us how big their brain was. So habilis would have a larger brain than Australopithecus. It's a common ancestor. Okay? But it was, again, it would have been short in stature, probably not the best in bipedalism, so it probably didn't walk all that well, not like we see with advances much later on. But we do know that because of the brain volume, that we found tools in association with these fossils. So we know that they had the ability to use tools. Is this very unique? Not necessarily, because chimpanzees, Pan genera, they use tools all the time. And they don't have to be taught how to use tools. They use tools themselves. They make tools and they can use tools. But Australopithecus, really, we don't normally find tools associated with Australopithecus. So that line kind of gave rise to this ability to utilize tools, make tools, this kind of thing. So this is kind of, the progression, or what we would assume these Homo habilis look like. Now, sometimes I'll get questions from students that say, well, how do we know that they were hairy? Well, we don't know that they were actually hairy, but based on the Pan genera and the fact that chimpanzees are hairy, we probably assumed, and it is an assumption, that our ancestors were also hairy. Now, if you take a chimpanzee and you shave a chimpanzee, you might be surprised, but their skin is white. So the hair is not just for warmth, but more than warmth, it's probably there for UV protection. We think that's probably what was going on with Homo habilis. And as they decreased the amount of hair, which happened clearly because we're less hairy than our ancestors were, they changed their color, especially in this region because they evolved in Africa. And so by evolving in Africa and being hairy, you could protect yourself from UV radiation. Okay? If you lose that hair, then your skin has to darken. So you have to have more melanophores, okay? Which would then produce, dark skin, which is also a sunblock or a UV block. Okay? And so you got, this kind of give and take. So either they were hairy or they were dark-skinned, black. Okay? But most of the evidence suggests that they were probably hairy. And that dark skin came later with human evolution. Okay, so from them we move to another species, okay, Homo rudolfensis, in which that, it was discovered in 72, at least the fossil was discovered in 72, and the difference between the two is really brain capacity. So this is why some lumpers will put the two together and say, well, brain capacity is not enough to say that they're separate species. They could have still been mating together. And, I'm not going to argue with a lumper and say that's not true. But based on the differences in skull capacity, there's a major difference between habilis and rudolfensis. Okay. The next line of Homo, or the next species in the Homo line, is ergaster. Okay. Ergaster was much different than habilis and rudolfensis, and pretty much everyone on the planet who studies human evolution would agree that ergaster was a different species. Ergaster had much larger brain capacity than rudolfensis or habilis, and they have a much more modern human skeleton. Okay, so they are diverging from their Australopithecus ancestors. So here's an ergaster skull, okay, and the brain capacity is much larger than what you see in earlier forms of Homo, okay, and much larger than we see in the Pan or Australopithecus or really any of the other genera that gave rise to the Homo line. So it's much more modern-like, and most people, if you found the skull, you would definitely consider it a human skull. Now, like I said before, fossils are produced typically when something dies and is buried in sediment and lots of pressure from water. Okay? So we know this, that early Homo populations, early populations of our genera, okay, there probably wasn't very many individuals. Okay? In fact, we think, based on genetic evidence, that there was very small populations of humans, and that they were just like eking out an existence. They were not, very large in number, and therefore we really just don't have very many fossils. Okay? We do find new evidence pretty much every year, new fossils or new bones and things like that, but there's just not a lot to connect all the dots. We know a lot more about other organisms, certain lines of dinosaurs, certain lines of fish, okay, because there's, hundreds of fossils versus, 5 or 10 fossils. Now, when we look at the two species that are accepted, we then suggest that Homo, the genera, went under adaptive radiation. When the genera itself started moving into new habitats, it started to become more adaptive to those new habitats, and you started to see new species popping up into existence. Just like we talked about when we talked about Darwin's finches or the Galapagos finches. When they made it to the Galapagos Islands, okay, and they made it to the different islands, all these different islands, all these different habitats, all these different niches, the species either evolved to fit the niche or it went extinct. The Homo line was the exact same way. Homo ergaster is often lumped with Homo erectus, okay? And it really just depends on, again, the camp that you're in. But we know that ergaster or erectus, whichever one you want to call them, okay, gave rise to what we call modern humans or modern Homo. Okay? And so that a much more modern skeleton than the other earlier Homo line, and therefore they, sometimes they get lumped together, but sometimes they're separate species. But nonetheless, they gave rise to what we call modern humans. Homo erectus is often called the true human. Right? And we have far more specimens of Homo erectus than we have of other species. Okay? And we have full specimens, so like the Java man and the Peking man. Okay, we have entire specimens of Homo erectus. So we definitely know that it had massive number of human features, and we can call it true human. So we know the human Homo erectus gave rise to modern humans, Homo sapiens. All right, when we look at erectus, it was taller, it had a larger brain than habilis, right? And most likely, based on the skull structure, so the jaw was smaller and there was less pressure on the vocal cords. So right now, if you look at, say, a chimpanzee, the reason why chimpanzees can't talk, it's not because their brain isn't capable of, speech. And they definitely can be taught sign language. Okay, and there's lots and lots of examples. You can look at all kinds of examples. There are symposiums all over the United States where individuals have taught chimpanzees how to talk through sign language. And we're not talking about teaching a parrot how to talk. Okay, that's mimicry. We're talking about teaching an individual, a chimpanzee, how to talk using sign language, and then they know how to speak to humans. So they can sign if they want to drink a water and they're thirsty, or if they want something to eat, or if they like your hat, or if they think you're pretty. All kinds of different ways in which they can sign. So they have the capability of speech through sign language. And that's chimpanzees. Okay? Way separated from Homo erectus. Okay? Homo erectus' jaw had been shrinking quite a bit, so it relieves the pressure, and that's what's going on with chimpanzees. There's too much pressure on their vocal cords. Their vocal cords, they can't vibrate their vocal cords in a way to make speech, or what we would consider speech. But erectus, on the other hand, because of the jaw relaxation and decrease in size, plus the larger brain, it suggests that they probably had the ability to talk. If you have the ability to talk, you're a social species, right? Which suggests that they moved in social groups, which provides a lot of evidence on how they lived and how they migrated and why they were not just found in Africa, but they're found in India and China and Asian regions. Okay. Now the oldest specimen of Homo erectus is from Africa. Okay? So it indicates that Homo erectus arose in Africa. So it evolved in Africa and then migrated out of Africa. Now here's the kicker. This is probably the interesting piece, and this is why I like to have Gen Bio students study human evolution, is when we talk about our impact on the planet, when we talk about global climate change, when we talk about ecology, extinction of species, how humans interact on an population or worldwide global environment, and genocide and all these things, we can look back at our ancestors and say, well, how long did our ancestors last? Okay. Homo erectus lasted just over 1 million years. Okay. So 1 million years. And that was longer than any of the other species of humans. So they were well adapted to the environment. So that's not to say at best Homo sapiens is going to last 1 million years. Okay? But odds are pretty good that you're not going to outlast your ancestors by too much. So it gives us kind of a point of reference. Well, how long does a species, especially a primate species like us, how long does a species like us last on the planet? Okay? About 1 million years. Okay? When we look at erectus, about 500,000 years ago, it disappeared in Africa. And we don't find any evidence of it in Africa after that. Now, in Asia, it survived a lot longer than that. Okay, so what does that mean for modern humans? Okay, depends on if you're going to lump Heidelbergensis, Neanderthalensis, and sapien together, but we first appeared in Africa about 600,000 years ago. Okay? So a lot of evidence suggests that modern humans might have outcompeted Homo erectus, their ancestor. They might have either killed them off or bred with them, so you no longer see Homo erectus in Africa. Okay? Now, it depends on who you talk to, and depends on the evidence that you look at. Okay? There are lots of individuals that say there was one species of human, modern human, and that's Homo sapien, and it arose somewhere around 600,000 years ago. But I would be willing to bet that there's far more people that think there is actually 3 species of modern human. And Heidelbergensis was first, and then Neanderthalensis, and then Homo sapien. Okay? So with that, we're going to move to talk about the evolution of just modern humans. Heidelbergensis, Neanderthalensis, and Homo sapien. Okay? Now, odds are right now, at least, probably as good to say that those are all just Homo sapien, and they outcompeted Homo erectus, Homo sapien did, or the odds are still in favor of saying that there's 3 species. There's evidence for both. There is very different skull measurements, very different fossil measurements for Heidelbergensis, Neanderthalensis, Homo sapien. Okay? We can't pull the genetics of Heidelbergensis, but we have pulled it from Neanderthalensis, and they are genetically different than Homo sapien. But is it enough to call them separate species? Again, depends on if you're a lumper or a splitter. Okay. So when we come back, we're going to talk about the evolution of Homo sapiens. And, for that matter, are we still evolving? Okay. Is the species Homo sapiens still evolving? And what's the evidence for Homo sapiens still evolving? Okay. So next time.